Hey gang, Math 1500, Fall 2014. These are the answers to the second part of the study guide for the final exam. Actually, I guess if we think about it, there are three parts to the final exam study guide. The first part was the multiple choice 10 question thing you guys did in class the other night. You've got this one, and you've also got your assignment on my stat lab. So you guys are really gonna be busy, aren't you? So anyway, question number one says results from a recent report indicate that 82% of U.S. adults owns a cell phone. Now, I would have thought it'd been higher than that, but what do I know? Um, so anyway, the 82%. When I see that, what you should sort of think is, you've got a percentage problem. Obviously, a proportion problem, and these things are handled a little bit differently than the mean problem. So 1A says if 2,000 U.S. adults are selected at random, then what's the probability that 1,700 or more owns a cell phone? So guys, we should know by this stage of the game that we're going to go to normal CDF to work this problem, or calculus. So we'll choose the calculator. And guys, it is so tempting to put that in your calculator, and some of you did back on the the second exam. But you got to remember that's 1,700. How many it's taken out of is an important part of the problem. So we've got 1,700 out of 2,000, and we want to run this to positive infinity because we want more than. And now we have to put in the mean. Well, remember the mean of this distribution is the percentage that we're given as a decimal, so that's going to be 0.82. And then we have to put in the standard error, which is the square root of 0.82 times 1 minus 0.82. Guys, I can see that that's 0.18. If you can't, just write that down on a sheet of paper and before you start the problem. And then we will divide it by the sample size so we can see that we took the sample of 2,000 adults. And I'm going to hit my right arrow to get out of there. Okay? Hit enter, and it looks like our probability is extremely low. Now, guys, it's going to be tempting there to put the probability at 2.396, but it's not because probability answers have to be between 0 and 1. And what you can see out here, you can see that this scientific notation tells us we have to move that decimal place 4 places to the left. So guys, the answer to this problem would be 0.00024. Now the next question says a random sample of 120 U.S. adults is selected and 100 report owning a cell phone. Now the way I would calculate and interpret the z-score for this sample proportion, what I would do first is I would put in the 100 divided by 120 and get the sample proportion, which in this case is 0.833. Now, using the formula, I know that I want to take that answer and I want to subtract it from the mean of the distribution, which is 0.82, and then I want to divide that by the standard error. And in this case, I didn't take 2,000 students like the previous problem. I took a sample of 120. All right. Now notice that everything is included under the square root. Some of you, I noticed in class, you try to put too much under there, and you get into an order of operations issue. And everything, the p, 1 minus p, and n isn't contained under the square root. So guys, we're going to get a z-score of 0.38. So let me remove the calculator. So the z, I wish I've left more room to write here, but I didn't. So guys, there's the calculation. So now we need to interpret. So we would say a sample proportion of 100 out of 120 is 0.38 standard errors. Guys, I'm going to abbreviate here because I'm running out of room. So it's 0.38 standard errors above the mean. Now let's get over there where you can see this. So 0.38 standard errors above the mean. Now guys, keep in mind you can always, pause and stuff. So I'll probably move at a little quicker pace than I do in class. Number 2. IQ scores are normally distributed, mean 100, standard deviation 15. What's the probability that a randomly selected person has IQ lower than 75? Well, let's reach for the calculator. Again, calculator or calculus, so I think we know which one we're going to choose. Normal CDF, and again, what do we want here? We want lower than 75. So at this stage of the game, we should know that that's E99. Lower than 75, mean of 100, standard deviation 15. Notice we don't have to worry about the standard error here because we're taking what's the probability that one randomly selected person. Okay. So gang, the probability would be 0.0478. All right, part B says if n equal 15 people is selected at random, what's the probability their mean IQ is lower than 92? Now, guys, this is a situation where we got to bring the standard error into the problem. So again, we want less than 92 with 15? Yeah, 15 people. So less than 92 is going to go negative E99 down to 92. With a mean of 100, standard deviation of 15, right? No. Guys, again, we have a standard, used a standard error here because we're looking at the distribution of sample means. So we have 15 divided by the square root of 15, okay? So the correct answer, 0.0194. All right, 2C, a random sample of 35 people is selected at random. Calculate and interpret the z-score if their average IQ is 115. So, unlike proportions, I can just type this directly into the z-score formula. So if the sample mean is 115, we want to subtract that from the mean. And we want to divide by the standard error. Now, guys, I have to put the denominator in parentheses. Otherwise, we get into an order of operations issue. So I have to take 15 divided by the square root of 35. And then I've got to hit the left or the right arrow and close that up. Guys, if I don't do that, I get an order of operations issue. If I eliminate these two parentheses here, it will take the numerator and perform the subtraction. It will divide by 15 and get an answer, and then it will divide that answer by the square root of 35. We don't want that. We want the entire denominator to be calculated first before it's actually divided. The numerator is divided by it. So guys, we get a 5.92 z-score. And what this tells us, it tells us a sample mean IQ of 115 for n equal 35 people. Is, I think the answer was 5.92? Yeah. 5.92 standard errors above the mean. All right. Problem number 3 is a weighted mean problem. So a teacher is teaching 2 statistics classes. On the final exam, the 20 students in the first class averaged 92, and the 25 students in the second class averaged 83. If the teacher combines the classes, what is the overall score? So guys, what I'm going to do here is I'm going to find the sum of the scores. Let me move this over a little bit. Well, I don't have room really. Okay. So I'm going to find the sum of the scores for the first 20 students. And let me show you where this comes from. Let me, back, you know, in the early stages of this class, we saw that the sample mean is the sum of the observations divided by n. And if we can multiply both sides by n, which n can't be 0, so that makes sense, we get an important relationship for these types of problems. It says that we can always find the sum of the scores by taking n times x bar. Well, guys, for the first group, we have n equal 20, and their mean was 92. So the sum of their scores has to be whatever 92 times 20 is. Same thing for the other class. There were 25 students. Sorry about that. And their average was 83. So we take the sum of theirs. Guys, we want a grand sum. And then we'll divide by, of course, the grand total. So that's the game plan for this problem. So, so we're going to have 20 times 92. Plus 25 times 83. And I want to get that answer. So the sum of the scores for both classes is 3915. Then I want to divide by the sum of the two sample sizes. So 20 and 25. And, you know, most of you are going to be able to do this problem. In your head, you can see the sample size is 45. But, you know, if we have a sample size of like 19 and 56, you may not be able to do that mental arithmetic on a test under the stressful moments of taking a test. So, guys, it turns out that the combined mean is 87. All right, problem number 4. You get a frequency distribution. Large class, about 100 students. And what we want to do is we want to find the interval in which the median grade is provided. Now, what I like to do over here is I like to do another column with the total. So I know if 42 students is in 91 to 100, then I have a total of 42 students in that that their grade has been accounted for so far. Now I have 31 students, so if I add that 31 to 70 or to 42, now I get 73, and then plus 16 I get an 89, and then I get a 100. What I'm looking for, since I have 100 students, is I want to look at the middle score. So that's going to be about in the 50th position. Well, my first 42 scores, and you can start from the top or the bottom, it doesn't matter. Let's just start from the top bottom here. Let's say 11, and I've got 27, and then 31 is 58, and then I've got 100 here. So I'm counting this way here, I'm counting this way here. It's going to turn out to be the same way. But if I look from the bottom, I got the first 42 students here. I know the 50th students because the top 73 students would be between 91 to 100 and 81 to 90. So I've got my concentration on where's the 50th student. If I were to arrange these things from high to low or low to high, where's the 50th student? Well, guys, I know it has to occur right here in this interval. Same thing if I count up here. My first 11 are in this group. When I add 16, then my first 27 are in this group and this group, and I get the 50th in the group 81 to 90. So guys, the correct answer here would be the 81 to 90th group. Guys, part 5, number 5, IQ scores are normally distributed. Oh, that's a typo. No, it didn't. No, it's good. I was thinking I wanted that question to be Z-scores. So I was thinking about what I was wanting to give you and not what I gave you. But this is what I gave you, so ignore me. Not totally, but ignore me in that situation. All right, gang, what's the percentile ranking? Guys, percentile ranking, if you think about that, what is it? It's just percent below. That's all it is, just percent below. So let's work that for 128. So if we find percent below, 128. All right. Always report percentiles to the nearest percent. So gang, the answer here would be the 97th percentile. What IQ is located at the 45th percentile? Well, guys, it's not asking you to find something that starts with a P. It's asking you to find a score given a certain characteristic, namely at the 45th percentile. Well, guys, inverse norm requires percent below as a decimal. That works out nicely because we're given the percentile, which is the percent below. So, guys, the IQ score would be approximately 98. That represents the 45th percentile. All right. So let's go to the back page. Now, the back page goes back, we get back here into a correlation regression issue. So let me put this up and we'll, I debated on whether or not how to handle this. I'll tell you what, let me let my dog in. My dog's going insane. There he is. Incredible timing. All right, let's keep the dog happy. All right, gang. I'm going to go through the entire steps here. So I'd want to go go to a stat, I want to use L1 and L2. So the first thing I want to do is clear out the data that I have. So I'm going to go clear enter or clear down. And I want to clear this out, so I want to hit clear, enter. All right. So I want to type my X's in L1, which would be 52, 77, 4, 5. Now, I like data sets like this because they're small, they're manageable, easy to type. So 80, 88, 80, 79, and 86, 85. Okay. Now, first thing, how would you describe the shape of the scatter plot? Well, we need to get one. So first thing I want to do, make sure I don't get any issues, is make sure your plot 2 and plot 3 are turned off. Now, if one of these is turned on, the easiest thing you could do is just hit the number 4 and then hit enter, and it'll say done, and that'll turn everything off. And I'll tell you what, let's just go ahead and do that because I don't want you guys getting into a situation where that would happen. So if I go either hit the number 4 or scroll down to number 4 and hit enter, it'll say plots off, and I'll say, well, yeah, that's what I want to do, and I'll hit enter, and it'll say done. Now when I go back to stat plot, I'm in a situation where I'm not going to get into a dimension issue by having a plot 2 or 3 turned on when I don't want it turned on. And we don't need multiple plots for this problem. So guys, the first thing I want to do is turn this on, so I hit enter. Next thing I want to do is choose the icon for the scatter plot. and then I want to make sure that I have L1 and L2. Now, what if you've got something like that there? You've got y and you try to change it to L2 by going second function L2. Well, it worked there. Sometimes it won't work. There's times that you have to hit your green key to move things in the proper stage of the alpha numeric buttons. So, all right. So let's go zoom 9, which is the easiest way to get the picture. And when we describe escape of escape of a shadow plot, oh my goodness! I'll tell you what. On that account, I'm going to take a drink of coffee. All right, gang. When you describe the shape of the scatter plot, you're looking for three things. You're looking for, is it linear? Is it positive or negative? Is it strong, weak? Is it strong, weak, or moderate? Well, guys, we have a linear relationship here. We clearly have a negative relationship. And we clearly have a strong relationship. Notice if I were to visualize a line going down through the central focus of the data, there's not a lot of variability around that line. The next thing I ask you is find and interpret the value for r squared. Well, guys, I'm going to let the calculator do the work here. I'm going to go over to test, scroll all the way to the bottom, and do linear regression t-test. Okay? Hit enter. Make sure you have L1 and L2 selected. Make sure you have 1 selected. We're not performing inference here, so we don't have to worry about this beta and rho. And it's nice to have the regression equation there. Now let's say that something's happened over the time and